Hi friends, welcome to another interesting math challenge. We have a very smart method. We are solving for angle QPR, that is this angle here. We see side PQ and side QS are congruent. Their lengths are A each, and we are given angles of 30 degrees, 70 degrees, and 75 degrees. With just these, we can crack the puzzle. Let's dive into it. To calculate the size of this angle QPR, we first assume its size to be R. Come to this triangle PRS, we have two of its angles to be 70 degrees and 75 degrees. We know that the summation of angles in a triangle is 180 degrees. So based on that, this third angle is going to be 180 degrees minus 70 degrees minus 75 degrees. 180 minus 70 minus 75 is 35 degrees. So the size of the angle is 35 degrees. Now from this vertex R, we are going to construct a line that's making a 70 degrees angle with this side. Call this point V. If you look at this triangle RSV, two of its angles being congruent implies that it is an isosceles triangle. The sides facing the congruent sides are equal. Hence, this side and this are congruent. So since this side has its length to be A, this must also be A. Still on the isosceles triangle, since this angle and this both are 70 degrees in size, we know this is going to be 180 degrees minus 70 degrees minus 70 degrees. 180 minus 70 is 40. But angle PRS, its size is 75 degrees. So since this part of it is 40 degrees, this must be 75 degrees minus 40 degrees, which is 35 degrees. If we look at this triangle PRV, this angle is 35 degrees and this is also 35 degrees, meaning they are congruent. So therefore, the triangle is an isosceles triangle. This side and this side are going to be equal. So since this side has its length to be A, this must be A in length as well. Okay, now the next thing we are going to do, we come here, this side QR, we extend it here to meet a perpendicular from this vertex P. Name this point A. Look at this triangle APR. This angle is right. That makes triangle APR a right angle triangle. We use a SOHCAHTOA on it. If we take this angle as theta, this is the opposite, say X. This is the adjacent, and this is the hypotenuse, say Z. Here, sin theta equal to opposite of our hypotenuse. Theta is 30 degrees, opposite is X, and hypotenuse is Z. So sin 30 degrees equal to X over Z. 30 degrees is a special angle. Its sine ratio is 1 over 2. So 1 over 2 equal to X over Z. We cross multiply. 1 times Z is Z, and 2 times X is 2X. So Z equal to 2X. That is, this Z is 2X. If you look at this angle AQ, it is an exterior angle of this triangle PQR. There is the triangle rule that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That is, angle AQT will be equal to the summation of this R and this 30 degrees. So it is R plus 30 degrees. We come back to this isosceles triangle PRV. This is its vertex angle. If we draw a perpendicular from it to the base, it's going to bisect the base. So since the total length of side PR is 2x, this segment and this each are half 2x, which is x. Call this point P. If you look at this triangle BRV, it is a right angle triangle. This side, its hypotenuse have a length A, and one of the legs, that is this, is x unit in length. Same is for this triangle APQ. It is also a right angle triangle. This is its hypotenuse. The length is A, and one of the legs is x unit in length. That suggests that the two triangles are congruent. So since this side x is facing an angle with a size r plus 30 degrees, here also the angle facing side x gonna be r plus 30 degrees. Undoubtedly, the size of the angle is 90 degrees minus this 35 degrees. So r plus 30 degrees equal to 90 degrees minus 35 degrees. 90 degrees minus 35 degrees is 55 degrees. Take this 30 to the right. 55 degrees minus 30 degrees is 25 degrees. So r equal to 25 degrees. Thank you for watching. Please like, share, and subscribe, and also turn on notifications. Thank you.